The date is July 20th, 2024. Minecraft speedrunner Couriway is live, working on his goal to complete the game 100,000 times, but something is wrong. Earlier today, his computer crashed in the middle of a run. Fortunately, he was able to turn back on his computer and finish the run.
Let's freaking go, sub 22.
An hour later, he generates his 3,606th run, and everything seems normal. He chops down a couple trees as he makes his way towards the ocean, hoping to find an ocean structure for iron ingots, but first he pauses his game to fix his headphones. And then, his computer crashed again. He returns a few moments later and is surprised to see all of his items are gone, and his position was reset. When Minecraft crashes, it's normal to lose a bit of progress, but he'd only just paused his game before the crash, which should have saved all his progress. He briefly quits the world in disbelief, and while Curry doesn't seem to notice it, if we look closely, we can see that the world just changed its name from a few moments ago. Curry goes on to finish the run without interruption, or so it seems. Hidden in the edges of the screen, unnoticed by Curry or his viewers, we can see that something unusual is happening to the terrain. Hard edges can be spotted off in the distance as Curry makes his way to his shipwreck, and then under the water as he boats to a buried treasure. The oddities only continue into the nether, as while he doesn't remember it yet, Curry has seen this exact bastion before only 3 years prior during a routing video he made for his YouTube channel. From here, he finishes out the run as usual, his first sub 20-minute time of the day.
Nice 8-bed 0, nice 8-bed 0.
And he's ready to start thinking about his next run. But first, he imports his world stats into his completion spreadsheet, and finally, he notices something wrong.
Oh, no. Dude. Average. Seed 0. Yup. That's the, we played on seed 0. Wait. Excuse me. Dude, how did, what? It's not actually seed 0. But like, it's just because the game crashed. I've literally done seed 0 for a video. This is not seed 0. There needs to be a fort 250-ish. Dude. I don't need, like, and look, there we go. Look at that. Look at this. What the flip is happening in my freaking world, dude? What is going on? What happened? This is not that insane. My Minecraft just crashed. I don't think it's historic. Let's relax. I don't think it's that historic. I don't know why it went to seed 0. I'm assuming it just couldn't figure out what to do and it like defaulted to that. But like, I don't know. Someone smart in Minecraft probably knows what the hell's going on. I have no idea.
So how did this Minecraft world forget its seed? Through my observations, there are 3 major symptoms that help us figure out what went wrong. First, of course, the world seed changed to 0. Second, the player lost their inventory and position. And third, the world's name changed after Curry loaded it. Oh, and by the way, all of this research is applicable to the version that Minecraft speedrunners use, which is Minecraft Java Edition 1.16.1. Before we can look into these clues individually, we need to know how and when Minecraft stores information about your world. A Minecraft world consists of many files, but for our investigation, we need to focus on just 2. The level.dat, which I'll refer to as the level data, and the .dat file stored in the player data folder, which I'll refer to as the player data. The game saves these files every 5 minutes, when you pause, and importantly, when you close the world or save the game. From my research, it seems that at the same time the computer started to crash, Minecraft also started to crash, prompting the game to start trying to save the world as it quit. Each DAT file is supposed to contain a gzip compressed MBT compound object. The gzip format is similar to the more popular zip format, though unlike a zip, it is intended to compress only one file. The file being compressed is an NPT object, the format Minecraft uses to store information about the world, its entities, and its players. Specifically, it is an MBT compound object, which contains multiple other objects such as numbers, strings of text, or another compound object. The game actually keeps a backup copy of these files, but as we'll see, these backups aren't always used. If you use an external tool to delete the seed from the level data, the game will simply generate a random new one when it loads. While perhaps a solar flare could have set the seed to 0, I found this unlikely, so I trawled through every mention of level seeds in the game's code until I found this. Minecraft has a robust process for upgrading old worlds to new versions called the Data Fixer Upper. As of Minecraft 1.16.1, these data fixers are responsible for upgrading worlds as old as 1.9. These fixtures include some updates you may have heard about, such as 1.13's The Flattening, as well as many you likely haven't. All the way at the bottom, we can see a fixer for upgrading to 20W21A, one of the last snapshots in the 1.16 development series. This fixer moves where several world generation settings are stored in the level data file, including the world seed. Importantly for us, it tries to move the world seed even if it can't find the old value, and it does so by defaulting to seed 0. This shouldn't happen in normal gameplay, but if we remove the data version field from the level data, the game adds a default data version value of 0, which makes the game think the world was generated on 1.9. This causes every single data fixer to get run, including this one, which completely overwrites the world seed with 0. Somehow, this is just about the only aggressive change I could find from a fixer. The couple hundred others seem to leave the world otherwise unchanged. With this, we can be fairly certain that the data version field went missing, but we'll loop back around to how that happened later. Next, I looked into how the player's data is managed to figure out the second symptom. For a single player world, the player's data is actually saved in 3 different places, although only 2 are checked when loading the world, leaving the third unused. The game first checks in the level data file under the player field, but if that's missing, it instead checks the file in the player data folder. Since Curry's player was reset, we can be fairly certain that somehow both of these copies went missing. Our third symptom, the changing world name, should start to help tie up this mystery's loose ends. When Curry originally named the world, he used the name of his most recent donor, MaxSan249. We had 16 prior worlds named after already. While Minecraft does allow you to use the same world name multiple times, it will quietly append a number to the end of the world's folder to differentiate them. However, when Curry first loaded the world after the crash, the world lost its custom name and defaulted back to the world's folder name. You can tell as it now shows the number twice instead of only once. This turns out to be a difference in how the game reads and validates the level data, and actually suggests that, yet again, the world seed almost wasn't lost. The class level storage source contains 2 different functions for reading a level's data. The first one is used to populate the list of worlds on the single-player world screen, while the second is used once you click Play Selected World and load into the world. We'll start with looking into that second one, since it's a little simpler. The code is intentionally fairly permissive to allow minor quirks in the loading and migration processes, though it does have a few requirements. The file must exist, it must be identifiable as a gzip file, and the decompressed data must be an MBT compound object. The other function, for loading worlds on the world screen, is very similar, with one major difference. It has an extra requirement that the level must have a version property field, which indicates that it was saved using the MC region or Anvil file formats, preventing any worlds prior to beta 1.3 from loading. In normal gameplay, this effectively prevents any very old worlds from being loaded, as they are hidden from the world list and thus unable to be selected or loaded. However, this difference in behavior presents an interesting oversight. When trying to load a level's data, the game will actually try to load it twice, once using the primary level file, and a second time using the backup file if the primary file fails. Let's suppose the level data was corrupted just slightly enough that it still parsed as a valid file, but it was lacking critical data. This hypothetical file would fail the level preview's 4th requirement of having a valid version, which would cause it to display the backup file instead, with the world name intact. However, the primary function lacks this 4th requirement, so it would load the main level data in spite of the corruption. This would cause the world preview to show a different file than the one that actually gets loaded when you select the world. Depending on how much data was cut out, this could remove the level name in every other field we've covered. Your computer somehow creating a perfectly corrupted file that meets the requirements in this exact way is easier said than done, however. To explain why, we need to dive into how the level data file is written to the disk. I created a mod that logs every write operation made to the file, and it shows that there are only about 6 operations depending on the size of the file. The first operation adds a header to the file, which is a very small bit of data used to mark that this is a gzip compressed file. If any part of this are missing, then trying to load the file would cause an error. The game then writes the rest of the file in 512-byte chunks. If this process were to stop abruptly at any point, then trying to load the file would fail due to an unexpected end-of-file error, as a decompressor is expecting to find more data to decompress. We need a way to produce what the game thinks is a valid compressed MBT object, while cutting out the important fields. This problem had me stumped for over a month before the explanation finally came to me. If the game were to write the header and the first 512-byte chunk, then the crashing computer were to experience an error while writing the second 512-byte chunk, it might have allocated more space to the file without writing the accompanying data. This would leave the file with just the 10-byte header, 512 bytes of the start of the compressed MBT object, and 512 bytes of zeros. The compression algorithm involves compressed chunks of defined sizes, so these zeros are treated as part of the compressed data chunk, and it tries to decompress them as such. This produces some invalid values, which can cause errors depending on the position in the object, but often it is decoded into more zeros, which generally perform some save action such as marking the end of an object. The game thus continues reading the dubious decompressed data until it tries to read the type of the next field and receives a 0, indicating the end of the object and safely exiting the loading process. Although there's actually one last bullet we just dodged. gzip compressed files are supposed to have a checksum at the end, which can be used to check if the decompressed data was corrupted, which it certainly was. Java supports this feature, but Minecraft doesn't use it, allowing the invalid data to be parsed as a perfectly valid MBT object, even though it's missing half its data. A few fields survive, including the difficulty, game mode, time of day, rendering trader spawn chance, and a few more, but the file cuts out in the middle of the dragonfight data, leaving out every single critical field we covered earlier: the file version, data version, player, and world name. This too is a miracle. The order of the data that determines what's kept is decided by the Java hashset class, which explicitly states that it guarantees no specific order. It just so happens that with this data, on this Java runtime environment, it outputs nearly all of the most important data at the very end of the file. So, without any further ado, here's the timeline. Curry's computer encounters an error which causes Minecraft to initiate its shutdown process. It successfully backs up the world's level data file and starts to write the new data file, but the crashing computer experiences an error which leaves the file half empty. At the same time, it starts to save the extra copy of the player data, but it fails completely to write the new file. When Curry loads back into Minecraft, the world list fails to load the primary level data as it's missing the file version, but successfully loads and displays the completely intact backup file. He then selects the world, prompting the game to once again try to load the primary level data, which this time passes all of the requirements, despite missing most of its data. Ironically, one of the surviving bits of data is the world seed, but it immediately gets overridden by the aggressive data fixer-upper. Every other bit of missing data is replaced with default values, allowing Curry to spawn with a brand new player on a brand new seed, keeping only his difficulty and the previously generated chunks. As soon as he spawns in, the game immediately saves the new level data file, removing every last trace of the original seed. It's hard to understate how lucky this was. If this had happened one version earlier, on 1.15, the data fixer would have not existed to reset and override the existing world seed, meaning the only loss would have been to the player data and the world name. Better yet, if the main level data loader had the same version requirement as the world list, the corrupted level data would have been ignored completely and the backup loaded instead, meaning nothing at all would have been lost. And that's not to mention the multiple different ways that the file could have corrupted more catastrophically, which would have left it completely unreadable and forced the use of the backup file. Finally, while I was recording clips for this video, I noticed the new Fair Play mod, standard on every speedrunner's mod list, replaces gzip with cryptozip in the .dat files. Cryptozip applies more rigorous checks for invalid data, which, as far as I can tell, means that this glitch would be impossible to happen today. Fortunately though, that mod didn't yet exist. None of the worst corruptions happened, and we got to enjoy this once-in-a-lifetime spectacle that I think truly embodies what the 100k challenge is really about. Alright, that's just about everything I've got. I did briefly look into whether this could happen on Minecraft 26.1, but unfortunately the update split almost every important bit of data into its own much smaller file, which just can't be corrupted in the same way. Researching this took over a month and even more to record and edit, so I would really appreciate if you could subscribe. I have a couple ideas for what to cover next, but I'd love to hear your ideas in the comments as well. But until next time, thanks for watching.
I'm pretty sure Maxon has had, like, some of just the absolute most insane worlds ever.